Okay, so what I'm going to do here is just a very quick problem. We're going to look at a long straight wire which carries a uniform line charge lambda surrounded by a rubber insulation outer radius A. And we want to find the electric displacement. So what I'm first going to do is I'm just going to draw a little schematic of this. So here's my long straight wire. This is the axis and it has a radius of A. Also carries a line charge, which is given by lambda. So the first thing I'm going to do is going to draw a little Gaussian surface on the inside. So here's my Gaussian surface. I'm going to let my Gaussian surface have a radius, which is given by S, and it's going to have a length, which is given by L. Okay. So now we go back to the equation that we found previously, where we have our surface integral of the electric displacement dot dA is equal to the total free charge which is enclosed. I put an ENC here for enclosed. So what's dA in this configuration? Well, dA here for our cylinder is going to be S d phi dz S hat. Okay. So when you do the integral, you integrate from z from 0 to L, for phi from 0 to 2 pi, and we have S. So it's going to vary as S. So now what we're going to get is, our integral is now going to become d by 2 pi S L is going to equal the total charge which is going to be enclosed, which is given by lambda times the length L. Okay, so now what we have is for our displacement, electric displacement D will be equal to lambda divided by 2 pi S in the S hat direction. Okay, so what we can also do is determine what the electric field is outside of our surface of our wire, and the electric field outside, since the polarization is going to be equal to 0, is just going to be given by E is equal to 1 over epsilon naught by the electric displacement, and what we're going to get here is going to be equal to lambda over 2 pi epsilon naught S in the S hat direction. Now one thing and this is for or much greater or greater than A. Okay, this is for the electric field outside of our wire. One thing to note is that we cannot determine the electric field inside of the whirl bubble because we don't know what the polarization is.